Hello everyone, welcome to a new video of a dynamics example. So the example of today is about rectilinear motion. So the example is from Hibbeler book, problem 1213. It says that tests reveal that normal drivers takes 0.75 seconds before he or she can react to a situation to avoid collision. And it takes normal drivers 0.75 seconds to react, and for alcoholic driver with 0.1% alcohol in their system, 3 seconds. So if the car is moving with 44 feet per second and can decelerate with 2 feet per second square, determine the shortest stopping distance for this car for both drivers. So let's lay out this problem. Here's the straight line path of the car, and we have the car at this location, and it takes the car 0.75 second for normal driver. So let's start first with normal driver. Okay, takes the normal driver, like here's t node equal 0 and t1 equal 0.75 seconds, to notice that there is a pedestrian at this location. Okay, so here, and we don't know t2. So we need to determine the distance. So this is what we call shortest stopping distance for the car. So let's call it S2. And the V at S2, like here, let's call it V2, should be 0. And we know that V node is 44 feet per second square. And also V1 equal to V node, but here the V is keeping decreasing until it gets to 0 was acceleration. So we know the acceleration is -2 feet per second square. So what we will do now, we will identify the initial condition at this point, and using this to get the state of the distance at this point. So let's start first with solving this part first, and then we will solve this part. So here the acceleration was constant, so the velocity is constant. Sorry, the velocity is constant, so the acceleration is 0. So we can directly use that. Let's call this S node, S1, and here is S2. So we can get S equal Vt. We know the velocity 44 in 0.75 second. This will give us 33 foot to do this distance. So this is S1, knowing that S node is equal to 0. So we got S1, 33 foot. So let's get to the second one. So here's an acceleration motion, so accelerated motion. So what we'll do, we know that A equal dv dt or v dv ds. When you integrate this equation, it will get like, it will get that v squared minus v node squared equal to 2as minus s node. So we know that v here is 0, so this will be 0, and we know the v node here, so we will get to 44 square will be equal to, and we know that this is -2, and we have s node. This is the s that we need to get, and s node is 33 foot. So we need to solve this for s. So you will get your calculator, and you will have 44 square over 2 by 2 plus 33. So this will be, because this is, I mean, like this should be this. So 517 foot for normal drivers. So let's, the second will be alcoholic drivers. For alcoholic driver, we will get S1 will be Vt, and we have same speed, but the time is different, 3 seconds. So when you multiply 44, give you 132 foot, and same equation, you will have negative 44 square to negative 2 s minus 132. Solving this for s, this will give us foot. So the shortest stopping distance for non-alcoholic driver will be 517 foot, and for alcoholic driver will be 616 foot. So just like almost 100-foot difference between them to react to pedestrian in this location. So this is like a simple direct example, and we will follow up with more examples.